Okay, so you're prepping for a senior software engineer interview, especially if it's a role that involves microservices. You're really going to want to pay attention to this deep dive today.
Yeah, that's right.
We're going to really laser focus on the system design aspects of it.
Yeah.
How do those little independent services all actually chat with each other and manage their data?
Absolutely.
This is the stuff that really trips people up, those architectural questions. And we want to make sure that you're ready to really shine when those come your way.
Yeah, and at the senior level, it's like you're expected to know what microservices are, right?
Right.
What interviewers are really looking for is, do you understand the complexity, nuances, and the trade-offs of actually designing them and operating them in a real system? How do you manage those dependencies, and how do you make sure that the data is correct across the whole system?
Yeah, absolutely. So in this session, we're going to be dissecting different approaches to how microservices interact and how they handle data. And we'll be looking at, what are the good things about this way? What are the bad things about this way?
Yeah.
And to make this a little bit more tangible,
Yeah.
we're going to use some scenarios from a fictional company called Musicorp.
I like it.
So imagine you're there, you're working at Musicorp, you're facing these design challenges yourself.
Yeah, and as we're going through these examples, think about how it relates to your own experiences and systems that you've worked on, or, those hypothetical questions that interviewers love to throw at you.
Right.
The idea is to help you move beyond just knowing what the words mean, and really get a grasp on the principles behind it all.
Yeah, absolutely. All right, so let's jump into it. One pattern that we see popping up all the time in these microservice architectures is what's called common coupling. So what does that actually mean in the real world, and why should we be like, oh no, not that?
Right. So at a basic level, common coupling is when you've got a bunch of different microservices and they're all relying on the same data store, like the exact same one.
Okay.
So that could be like a shared relational database, a common cache, or even like a shared file system. The key takeaway here is that while sharing data might seem like, oh, this is efficient, this is easy.
Sure.
At the end of the day, it ties the life cycles and deployments of all those services together, even though you want them to be independent.
Gotcha.
Yeah.
So like at Musicorp, for example.
Yeah.
Let's say they have like an order processor service and a warehouse SATA, and they both need to know like what countries does Musicorp operate in. It might seem like, well, it's really simple. They can just both hit the same database and get that country static data.
Right. And it might seem harmless, especially for data that changes very rarely.
Yeah.
But it still creates this dependency,
Okay.
So like, let's say you have to change the structure, the schema of that shared database.
Yeah.
Even for something as simple as the country data now, both the order processor and the warehouse service, they need to be updated to handle that change. Yeah.
And they have to be redeployed at the same time.
No, that doesn't sound fun.
Yeah. And it can cause like all sorts of problems and unexpected disruptions,
Wow. Okay, so even with data that's like pretty stable, there's still kind of a hidden cost there in terms of like how much coordination you need.
Exactly.
But it sounds like where it really becomes a headache is when those services are not just reading the shared data, but they're actually writing to it as well.
Yeah, you're spot on. Let's go back to Musicorp for a second.
Yep.
Imagine both the order processor and the warehouse service are working with the same order record in a shared database.
Yeah.
So maybe the order processor is the one that sets the status to like placed or paid. And then the warehouse updates it to picking or shipped.
Okay.
And maybe both of them even have the ability to mark an order as canceled.
Oh, yeah. That's when it feels like things could really get out of sync.
Exactly. And this is where we get into the world of state management.
Which is basically, how do you control and update the data that reflects like the current status of something in the system?
Right.
So when you have multiple services all trying to change the state of the same thing, like an order, you need a really clear and consistent way to manage those changes.
That's right.
Otherwise, you're going to end up with a big mess of inconsistencies and a system that's really hard to understand and fix.
Oh, I can only imagine the debugging nightmares.
Yeah, exactly.
So how do we bring order to this potential chaos? I've heard of something called a finite state machine being used at Musicorp. What is that all about?
Yeah, so a finite state machine basically gives you a blueprint for all the valid changes that something can go through.
Okay.
Like our order in this case. So think of it as like a well-defined life cycle.
Okay.
With specific stages and rules about how you can move between them.
Gotcha.
So for Musicorp, they might say an order can go from place to paid, then to picking, and finally to shipped.
Okay.
And they might also allow you to cancel an order from any of those states.
Right, makes sense.
But a key rule might be that you can't go directly from place to shipped.
Okay.
You have to go through those intermediate steps.
Right, so it forces you to follow a logical flow.
Exactly.
But going back to our multiple microservices problem, how do the order processor and the warehouse actually stay in sync on those allowed transitions if they're both hitting the database?
Right. It can't just be a hope and pray situation.
Right. It feels like it's kind of relying on everybody to play nice.
Exactly. You've hit the nail on the head.
Yeah.
This is where this idea of a single source of truth comes in.
Okay, so instead of having like both the order processor and the warehouse writing to the order status, we pick one service to be the boss of that data.
Exactly. A much better way to do this is to have a dedicated order microservice.
Okay.
That is the only one that can manage the state of the order.
Okay.
So now in this model, the order processor and the warehouse, they don't update the order record directly anymore.
Oh.
Instead, they send requests to the order service. So like the order processor says, hey, order service, please update order number 1, 2, 3 to paid.
Exactly.
Then the warehouse says, hey, order service, please update order 1, 2, 3 to ship paid.
Right. They're basically asking permission and saying what they want to do.
Yeah, instead of just barging in and changing things.
Exactly.
And that's where the order service gets to flex its muscles and say, no, 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 you can't do that.
Exactly. And this is a big change in who's responsible, you know.
Yeah.
Now, the order service is the one that looks at these requests and compares them to that state machine we talked about.
Okay.
So if the warehouse tries to jump the gun and say, I want to mark this as ship paid, even though it hasn't been paid yet,
Yeah.
the order service can and should reject that request.
Oh, because it knows the rules.
Exactly. It's enforcing the rules.
Okay, so that makes a lot of sense. You're putting all the logic about how an order should flow in one place, and that really reduces the chances of things getting messed up.
Mm-hmm.
It's like having a referee
Yes.
who makes sure everyone's following the rules of the game.
I love that analogy.
Now, I do want to contrast this good approach with something that might sound similar, but is actually not so good.
Oh, okay.
You might see systems where there's this thing called an order service,
Uh-huh.
but all it really does is basic database stuff like create, read, update, delete.
Right. It's just a thin wrapper around the database.
Yeah, so when the order processor or the warehouse asks it to do something, it just does it.
Yeah, it doesn't actually check if it's a valid move.
Oh, so even though it's called an order service, it's not really in charge.
Right. It's not the one orchestrating the process.
So we're back to square one with all that logic spread out all over the place.
Exactly. And that defeats the whole purpose of having this dedicated order service.
Yeah.
You know, the rules about what's a valid change are still all over the place. And that means the services are more tightly coupled and there's a higher chance of things going wrong.
Right. So a well-designed order service isn't just about giving access to the data.
Right.
It's about actually enforcing the rules of the business.
Right. Exactly. It's the guardian of the business logic.
Okay, so now beyond all this talk about keeping the data correct,
Yeah.
there's also the performance aspect to think about.
Yeah, absolutely.
Like with our shared database example.
Right.
What if you have tons of services all hitting the same database at the same time?
Mm-hmm.
Especially with like really complex queries.
Oh, yeah. You're going to run into problems.
It's going to slow everything down.
Exactly. You can get resource contention,
Oh,
which means all the services slow down,
yeah.
or the database might even just get overloaded and crash.
Oh, no.
Yeah, I remember one time there was this poorly designed report query running on a shared database, and it actually took down the whole ordering system during the busiest time of day.
Oh, no.
Yeah, it was a big mess.
So it's not just about keeping the data in sync. It's about making sure the system as a whole is stable and performs well.
Exactly.
Yeah.
Performance is super important.
So just to recap common coupling, especially when you have multiple services reading and writing to the same data,
right.
can create a whole bunch of problems.
Yeah.
It makes it hard to change services independently. It increases the risk of bad data, and it can hurt performance.
Exactly.
So the alternative we talked about with a dedicated microservice that's in charge of state for a core entity, like an order, that gives you much more control and makes the system more resilient
Absolutely.
by making that order service the single source of truth and the enforcer of the business rules.
Yeah.
You get way better control. The data is more likely to be correct, and you're much less likely to run into those invalid state transitions.
That's right. And understanding these architectural patterns and the trade-offs is so important for senior engineers.
Yeah.
You know, in an interview, you want to be able to talk about these things clearly.
Yeah.
And using examples like our Music Corp case will really show that, you know, how to build systems that are strong and scalable.
This has been really insightful.
Good.
As you're prepping for those interviews, take some time to think about systems you've worked on. Have you seen any examples of shared data or state transitions that weren't managed well? What problems did that cause? And could a more centralized approach with a state machine have made things better?
Great questions.
Thinking about your own experiences will really help you understand these concepts and give you some real-world examples to talk about.
I agree.
Thanks for taking this deep dive with us.
It's been a pleasure.
Now here's something to think about. What if you have a system where a single service is getting slammed with requests to update state?
Okay.
What are some ways you can handle that bottleneck without compromising the integrity of the state management? It's a tricky problem, but it's something worth considering as you prepare for those interviews.
Definitely food for thought.
Thanks again for joining us.
My pleasure.
We'll see you next time.